All right, hey everyone. Hey everyone. Are you having a good time? Ooh. Okay, clap once if you could all hear me. Okay, clap twice if you can hear me. Okay, anyway, so we are putting up the list of all the groups in presenting order right here. Yeah, thanks for setting up the gallery. We're gonna let everyone get a chance to present. The presentation rules are as follows. You get 4 minutes to present. Please try to explain your idea, show it if you can, and try to be as succinct as possible. And the judges here are all real experts. We will put, I guess we already shared their names, but if you guys can stand up and please give the judges a round of applause for taking the time to judge you guys. So we've got Brenda Rios, who's, okay, I'll go from that side. Brenda Rios from HCC, Director of Student Innovation. Dr. Maya Dernovo, who was here last year as well. Jessica, who is Brenda's sister. We have Ned, who is business development entrepreneur, entrepreneur in residence at HCC. He's a cool dude. You should learn a lot from him, especially if you're thinking about taking any of these ideas into turning it into an actual product. And we have Marcella Watkins, who used to be a patent attorney at a really big oil company. And again, if you want to take any of these ideas and turn them into real products, you should definitely talk with her as well. Cool. So with that in mind, let's get the final presentation started. Jolt is ready over here. And second is Project Icarus and Energized Exhaust. Please get your stuff ready. And we will be starting Jolt right in... Okay, make sure you guys fix that.
Your docs are not public. I can't see the presentation here. So you have to check the box that says make public. So for every team, make the presentation, go under docs,
yeah. So all of you guys, whoever submitted, make sure that your presentation document is public. So go into your idea, go to docs, and make sure that your PowerPoint presentation is public, because otherwise we can't see it. And yeah, so 3 minutes, please check your submission. Cool.
Go to the docs tab.
Yeah.
I just wanted to tell you guys that the event is being publicized on YouTube. So if you search for Innovation Lab or HCC Innovation Lab or on Facebook, Inventor Space, the event is being live streamed. So
Share it with your parents.
Absolutely.
Share it with your friends.
Share it to other people who are not here. Could also be, so I'm going to take a white selfie. So I'm going to start from
Okay, we probably need to move that table a little bit.
Good morning, everyone. Good evening. Yeah. How many times have you found yourself looking for a wall outlet because your phone is dying or your laptop needs to be charged? And don't you sometimes just wish like your battery could just charge itself magically, right? Can you move to the next slide? So this is exactly what we made here. This battery charges itself when you shake it or make any sort of motion.
Now you might be asking, how does this work? The system's pretty simple. It converts all your mechanical energy, all your motion, straight into electrical energy through Faraday's laws. Switch it. Now you might be saying, I've seen this technology before. You've seen the shake flashlights that charge over shaking. Well, it's the same concept, yet we improved it to make sure it's much more efficient. We've done many things to make it more efficient, including using a lot more wire, 400 feet in this case, with over 2,000 loops. The shaking of the battery produces AC, and usually how you would convert AC to DC is through a rectifier. Instead of going through a rectifier, we use a bridge rectifier circuit, which more efficiently, basically a normal rectifier would have half the voltage. This keeps the voltage the same. We also go straight into a capacitor that can smooth out the DC voltage to charge the battery in an efficient manner. All right,
So these are essentially our numbers. Nobody probably wants numbers here, but this is what we did here. It's the voltage we produce is exactly the same amount as a normal AA battery. And the good thing about this battery is it fits your basic form factor. So you don't need to change your existing technology to fit the battery. This will fit whatever you already have.
So as you guys can probably already tell just by holding that, it's a little bit bigger than pretty much any other battery that you've ever used. That's a larger prototype. To make it in the clear resin, it ended up having to be a little bit bigger, and just to make everything displayable. We typically keep them in a little bit smaller, this about that big, that's a D cell size. And we have several designs. So we have the standard battery, which is a D cell, and a holster for it as well, which will go onto your ankle. And you can shake it while you're walking, essentially. And then we also have this one, which will charge through the same mechanism. Essentially, it's the same mechanism here. But instead of routing to an internal battery, it'll route to any external. Right here, it's a AAA rechargeable battery. So whenever you shake this, instead, it will charge this battery. If you want to pass it around, you can. And then we're developing one for a smartphone that you slide in your smartphone battery, pop that into your case, and it'll end up charging it through the same mechanism as you walk. It'll shake back and forth horizontally, and it'll charge your smartphone battery. Big thanks to Mr. Fields for letting us use the 3D printers and helping us out, because we designed all these in SolidWorks, but ended up being a wire. We needed a whole bunch of help. It was great. Yeah, well, again, I said we used Mr. Fields 3D printers, and the electronics were obviously designed and tested outside of the cases before we put them in. That way we can, not have them non-functional. And the coil was wrapped by using a drill press. We stuck the cable on there, and we twirled it around. That we didn't have to twirl it by hand for hours. And yeah, we obviously changed the size and shape for different purposes, display and actually for use.
Just before we end real quick, I've been charging this battery all day. It's been on my ankle all day. And here, let me just demonstrate it real quick. So this lamp, it basically has 4 D cells, but one of them is dead. Hence the really low brightness. Now, I'm going to switch one of the batteries out for the one we have. And this is afterwards. Thank you, everyone.
Hello, I'm Lucas Groves.
I'm Neil Layler.
I'm Mitchell Harper, and we are all students at Memorial Middle School. Oh, I'm sorry. Okay. There. Okay. So we have designed Project Icarus, which we don't have a model of because we weren't able to get in time to 3D print. So. All right. Okay. So is that good? All right. Okay.
So basically, the intended purpose of Project Icarus was to create a new and renewable energy source, which is much more effective than solar panels back on Earth, because 70% of all solar radiation that solar panels collect is absorbed by the atmosphere or dissipated by the atmosphere. But if you go close to the sun, outside of the Roche limit, of course, you can get 100% of that energy, depending on the solar panels you use.
The dimensions of the craft, which may seem a bit absurd until you consider the amount of energy that we're going to attempt to collect with this thing, are 800 meters tall and 154.26 meters wide, which is very, very big. And the total surface area of the solar panels, which we are planning to cover the entire craft in pretty much, are 6,301,582.324 meters squared, which is a lot. So,
The first thing we did here was we calculated the surface area of the satellite by figuring out how many solar panels we needed. We calculated about 1 meter squared of multi-junction solar cells, which have an output about 476 watts of energy per meter squared. We increased this value by 70% to account for the lack of atmosphere and 70% dissipation of energy. Our total was 728.46 watts per meter squared. To power the top 3 countries, we need 9,180,902,170 kilowatts. After that, we calculated how much energy would be lost over time using the formula Q equals Q0e to the power of negative TR squared. Half. Thanks, Mitchell. We estimated about 8.2 million watts would be lost per hour. The estimate of the cost of this project is about $80 billion, which is a lot until you realize how much power this will generate and how many countries will be working together to attain this level of power that everyone can share.
After launch, we will use Earth's gravity as a slingshot, which we can also capture the mechanical energy of the slingshot as power. But slingshotting the satellite into space, once flung, the ion thruster will start accelerating up to speeds of 200,000 miles an hour. The starting speed will be around 600 kilometers per hour. We predict if everything goes to plan, the ion accelerator will be going at maximum speed in about 3 days. It will take 19.4 days to get to the sun and 2 months to orbit. So you'd orbit and then 19.4 days, we estimated around, I think it was 4 months to finish the process. Then using the sun's gravity, we are going to launch this the spaceship again, just like a gravity slingshot, the way that we got back.
all right, so for the price of this thing, it's kind of costly, as we did mention before, at about $40 million per craft because, you know, it's $80 billion for 2 crafts. So although there are many benefits to this plan,
it'll be $171 per meter of solar panels. We'll be spending $40 billion on solar panels per ship, which there will be 2 satellites. We also need an ion thruster, which we calculated roughly $13.6 million to fill up, which using fuel of xenon, and around $50 million for the actual ion thruster. It doesn't take up space. The benefits: it doesn't take up any space on Earth. It would create a very beneficial socioeconomic climate between Russia, China, the EU, and US, because they will all be benefiting from this energy source. Nations with energy deficient would no longer have to trade with other nations to acquire the energy that is essential to their society.
55,120,140.2 kilowatts produced per day. So that's 479 billion kilowatts per 1 rotation around the sun, which isn't accounting for the energy that dissipates over time, of course. Or, to put this into perspective, the average person uses 2,674 kilowatts per year. The sun puts out 3.86 times 10 to the power of 26 watts of energy per second. With just one satellite, we can power the entirety of Russia. Imagine what we can do with 2 satellites. going around per year.
So this is a rudimentary drawing of which we created of the craft. Pretty much just a large cylinder with two gigantic areas, mainly used for solar panels, of which both sides will be used because, you know, the thing's going to be rotating. All right, that's...
This is just the orbital pattern that we plan today.
Launches around
The
Earth.
ISS will catch it here and here and here. Hopefully.
All right. Thanks, guys. All right. The energized exhaust. You guys can get ready. Go ahead, set up. And what's the thing? I'm gonna try. Yeah. But just watch the wires. If you want to go around, yes. Okay, that's fine. You'll be here. Just gotta click. Watch the line. All right, ready? You guys ready? Yes?
Good evening, ladies and gentlemen. My name is Jefferson Yu. Our product is the energized exhaust. Primarily, we'd like to give a big thanks to all of the sponsors, teachers, and mentors here at HCC throughout our journey at inventathon.
Almost every day, millions of people use cars to commute to various places. Cars produce staggering amounts of CO2, and besides it being wasted, it is also a deadly cause of pollution. Is there any way that we could harness the power of carbon dioxide?
So some major statistics that we found were that the average car produces 6 tons of CO2 per year, and carbon dioxide pollution costs $40 per ton.
The energized exhaust stores CO2 produced by cars so that it can be turned into energy through a chemical reaction between carbon dioxide and another compound, lithium nitrate.
This reaction between carbon dioxide and lithium nitride has many advantages. Primarily, this reaction can heat up its surroundings to about 1,000 degrees Celsius, which can be used to create steam and therefore turn a turbine to create energy. In addition, 3 byproducts are made by this reaction, one of which can be used to make agricultural fertilizers, another can be used to make adhesives and construction materials, and the last one can be used as a semiconductor in photovoltaic or solar cells.
So here's a animation that we made for our model. Due to material and time restraints, we were unable to do 3D printing, but we've made this model for everyone to see. So this is a little zoom in of the model. So basically here we have the tank where the CO2 would be stored. This is the current exhaust pipe in many cars. Here we have a connector so that the CO2 can flow down into this area. This would be the area for a air compressor so that we can store and cool more air into this tank area. And here we have valves, which we'll explain in a second. So here are the different parts. We have the exhaust, the valve extension, the connector, and the tank. So our design features special valves. So when the car starts, the primary, which is this valve, it will open. So the insertion will come up, and if the tank is not full, then the secondary one will also open. It'll come up, but it'll still stay inside here. But this way, the CO2 can float into the tank. However, when the tank is full, this one will come down, and this one will come all the way up, so that the CO2 can escape through this hole, and so the tank will not explode or cause any damage.
So the exothermic reactions that we're using can create a lot of heat, which can produce steam that can turn turbines to generate more electricity. So for convenience, we have provided the chemical reactions that show how this is all done.
Our system is envisioned as a fleet of trucks, similar to what you would find in current waste disposal plants, and each truck would stop at each driveway and pick up the tanks of full CO2 and deposit empty ones for the owner to use. And then the tanks would be shuttled to a power plant to begin the reaction with lithium nitride.
Once the CO2 arrives at the power plant, it would be moved from its container to a larger gas storage chamber. And this gas chamber would be made out of pure iron. This is because iron has a melting point of about 1500 degrees Celsius and is about 24 cents per pound when bought in bulk. And it's also a good conductor. The CO2 would then react with the lithium nitride and create these temperatures, as well as the three byproducts that we have already talked about.
So the solvency of our product solves this problem very well. In addition to stopping dangerous pollution, the energized exhaust also produces electricity with the generated heat, and it also produces these advantageous byproducts to improve society. So this isn't any regular convenience product that you use for convenience, but rather this is a life-changing product that will allow more people and more humans to survive on Earth.
So the total cost of our product consists of the tank, the connector, and the condenser. And this would amount to around $100, but we feel this is a very small price to pay, as people pay tens of thousands of dollars on cars. And $100 is nothing compared to this to be able to save the environment and produce a lot of energy.
Thank you for supporting and voting for our product.
Our project is over offshore drilling safety, and it's focused mainly on the oil rigs that are out in the bodies of water that aren't close to land.
And so as Houstonians, our economy is centered around oil, and oil is really important for all of us. And so we immediately thought, what are the biggest issues in the oil industry? And the answer is simply oil spills, because oil spills cost a lot of money and they hurt the environment. And in fact, between 2003 and 2013, 1,189 oil and gas extraction industry employees died while working. And so this means that there is an average of 108 deaths per year. And so one specific instance we looked at was the BP Deepwater Horizon disaster, which was owned by Transocean. So it's this oil rig that exploded off the coast of Louisiana and burned for 36 continuous hours before sinking, and 11 crew members died and more were seriously injured. And so there was extensive damage to the environment and Gulf Shore communities. And in fact, BP estimated that the total cost of this was $65 billion as of January 2018. And moreover, there was this huge loss of animal life. 82,000 birds died, in addition to 26,000 marine mammals and 6,000 sea turtles. So there's a lot of damage done by the BP Deepwater disaster, and it was considered one of the worst ecological disasters of all time. And so we tried to fix today's problem. And so we thought, who is affected by oil rigs? And obviously, everyone is affected by oil. But more importantly, the 11 people who lost their lives forever, and we're never going to have them back. So our first solution for safety was the capsule, which would be an escape pod for individual extraction and increased rescue efficiency. But we also came up with 3 additional solutions for oil rigs. And they're the buoyancy platform, which would store the excess oil from leaking out into the water, the deployable oil boom, which traps the oil within the circumference from spreading out within the water, and the plastic cap, which is placed over the drill to prevent blowouts and instead transfers the oil into pipes that bring it into the basin, which drains it into the pontoon. So overall, this helps fix the environment, helps fix legal issues, and in the end, it helps the oil companies retain oil and make bigger profits.
Okay, so for our design, we weren't able to bring a life-size oil rig to work with, of course. So instead, we used 3D modeling, and based off of a 3D model of a semi-submersible oil rig, which is what the BP disaster oil rig was, the type of oil rig it was. And we made some edits onto that will show like our implementation of what our solution would be. So for this one, this would be like a cap over the drill in which the oil comes from. So most oil rig explosions or problems, oil spills, occur because of oil blowouts, where the pressure of the oil beneath the ground is too high and it shoots up too fast to be contained. So for this, would basically be a plastic covering over a general area of the drill, allowing the oil to hit the plastic covering and enter a basin here to collect the oil, which then funnels the oil into the pontoon at the bottom to be stored. And since oil is lighter than water, it is able to replace air as like a flotation mechanism. Here we have the perimeter covered in a oil boom, which will be able to be deployed. So it's not able to be perfectly modeled here, but essentially we would have something to launch the oil boom into the water, surrounding the perimeter of the rig and containing the oil in the water before it expands. And finally, these are capsules. So if you go on to the next slide for a more detailed look, this would be a safety capsule where the oil rig workers would be able to evacuate individually. So these are our costs, and so escape pods, they're based on however much materials would be needed for the oil rig. They wouldn't be, they aren't calculated with, do I have to stop or should I? Okay, so they aren't calculated with application costs, they're only calculated by materials, but this is still a lot cheaper than the $65 billion, which would be wasted if an oil rig explosion would happen. Yeah.
Dara Haddon, and I'm here to present you the green amp. This was more of a personal research project that I did to further my knowledge in electronics and solar power and ooh. If it's not on fire, it works. That's all I can say. So I modeled this to fill a need for a renewable source of guitar amplification. So the original schematic that I found online used a solar panel that I put a 9-volt DC at 100 milliamps and used two 220 nanofarad capacitors or 2200 nanofarad capacitors to smooth out the signal for the amplifier to I used an LM386 amplifier IC, and I later modified this to have the battery in it, which has now exploded. That's not a good thing. Let me go back. So the battery is in there because the solar panel doesn't output enough power for the amplifier to actually run, but it does have enough power to charge the battery, and the battery will output the right amount of power because it's charged up. This was the first electronics project that I've done, I think. I've done some smaller ones with the snap-on kits and stuff that spin fans or whatever. So this was a bit challenging. In here I used a proto board. I wired up all the parts onto it, which was very interesting as I had little to no soldering experience, which might be why it set on fire. Maybe. So because of its ease of use and everything, I just used standard project foam for trifolds and stuff to make the structure. I upcycled some, I think this is paper towel that I used for the grill speaker or the grill cloth. So the final product ended up, so it sits on top and you plug all the cables in and everything. It stopped working for some odd reason. So I made it to be an off-the-grid guitar amplifier so that you can play wherever you are without need for a very long extension cord or anything else. Right, I think that's it. Thank you.
Oh yeah, hello, I'm Abhinav. So,
Basically, the problem that we found was so although hydropower stands as an energy source researched by every major energy company, the small scale utilization of hydropower is under researched, even though it's capable of acting as a major power source for thousands of homes, only requiring a small source of flowing water. Also, there are 700 million farmers who do not have access to electricity. And so what we felt we wanted to do when we were, inventing was we were going for practicality rather than something small like a gadget. So we tried to do something as pervasive as possible. So.
okay, so for a basic overview, this is just like a general picture of how our system is going to work. So basically, our first solution is ground tapping. So as you know, many power plants, many groups of other farmers, they can't bring water up, and they have very expensive electricity bills, about 25,000 per year. So what we did is we created a $50,000 system which can easily bring all of their electricity bills into one specific fund. So what this basically does is goes here. Okay, so basically what happens is that when you put like water, like a river source, for example, into that, we create the water that starts going up because of pressure. So originally all there is pressure. And from that pressure, we create gravitational, convert all of that into gravitational potential energy. And when that's converted, we convert that all into fluid kinetic energy, which then spins the turbine and creates electricity for everyone else. So now we also have two other portions of our project, which basically help companies and normal users. So this was just basically some specifics of the project and how much it costs, and like it can power up to 15 different houses, and we can have bigger scale and smaller scale models. And this is very convenient because it can work in any small creek or stream or anything else. So now this is the second part of our project. So what we wanted to do is help companies figure out which factories are the best for themselves. Because this is a major problem. We have so many factories in our environment today. They don't know which factories are good. So we created like a network, we created a program that lets companies, they can just import our data and it'll rate their factory and tell them what to do with it. Should they destroy it? Should they break it? And this is based on 5 separate variables. The variables may include cost, benefits, how many people have access to it, etc.
So basically, so the third section that he was explaining earlier was the economic investments. So as the stock market continues to develop day by day, we see thousands and thousands of just Americans trying to, set up their retirement, their 401k in the stock market. So what we did here was we created an artificial neural network to help analyze different stock market trends. And so here, for example, he used 5 different major companies today. So he used Oracle, Energy,
Exxon, Microsoft, and Apple.
Next slide, please.
The application of mini hydropower systems is purposed for those located in rural areas near a source of water in need of an accessible, affordable power source. It will provide a constant source of energy to the people using it, and with so many places to be used, it will become an enormous source of consistent and renewable energy throughout the world. The effect on pollution with the increase in use of this hydropower or renewable energy source is extremely important.
We'd like to say a very, very big thank you to just all the staff, volunteer judges, and HCC. Just thank you for allowing this event to take place. Thank you so much for just taking your time to be here for the preparation and everything. We felt like it was just such a big commitment taken away from your weekend, because I know I had to skip,
Thank you. Thank you.
Thank you so much.
Hello.
Hello, everybody. What a nice afternoon we have here at HCC Stafford. So, I hope you guys enjoyed this inventathon. My name is Bill Wynn.
My name is Daniel. I'm Tanae.
And I'm Rohan. And today we will be talking about jumpy feet or power flops, as we renamed. Why, you may ask? Well, have you ever struggled to find like materials online that are super overpriced? Do you know those countries that don't have water or electricity, and you need energy and you need money to be able to supply that energy to the people instead of just wasting it on, you know, turning the AC on in cars whenever you're stopping at a red light, or even afford cars for that matter? So here, when do we use this technology? Well, first of all, these are slippers, very cheap slippers in fact. All of the circuitry and everything, it costs total less than $5. We picked them all up at Walmart. So these can be worn anywhere. In fact, I will demonstrate to you right now. Our model, Daniel here, walked around HCC at least 3 laps testing this. So this is a picture of New York, you know, a very densely populated and pedestrian-heavy state. So this is where the technology comes into play. By prioritizing walking, not only are you encouraging exercise, you're also limiting the usage of automobiles, which then in turn limits the cost of power. And by generating your own power, you basically have a double-pronged attack on the problem that we have of conservation.
Okay, so how we did this concept was using piezoelectric materials, these 3 igniters right here. We basically connected it so that whenever we press down on it on our foot, it would strike and make a quick electric current. So next. Okay, next. So what we found out, however, are a few problems. For example, one of these we estimated to be about 1,000 volts, each one of them, every time we push down on it. And so that means it's about a total of 3,000 volts every single time we step. And that the issue is that we don't have a battery that could take all that without, you know, blowing up.
So because the voltage is so high and it's in short bursts, we had to use an inductor and a capacitor. What they do is not only they store the power, but because the capacitor has a limited capacity, the inductor feeds the current through the capacitor, which causes the voltage to collapse, and therefore giving us a smaller voltage that we can possibly work with. After experimentation, we found out that a few steps we will charge up enough battery for this battery, which is a 3.7 volt LiPo from a drone that he butchered himself. So this current can charge the battery for an approximate of 5 seconds. So this is just, you know, a joke. Well, yes, it's indeed 3,000 volts, and we are not crazy because we've done research on this. We're only students, but nowadays you can learn anything online, right? So we used a breadboard under our slipper to show that we do not need excessive wiring to actually perform this feat. So these are just the pictures. Thank you so much for watching. I would like to thank all of the sponsors for this event and a lot of people that helped us achieve this. Thank you so much. See you next year.
Hi there, this is Risha.
This is Ruth.
And we both are inventors who who want to change the world. And I, Dhruv, I'm 12 years old in 7th grade, and I designed the model of prototype 2.
I'm Risha Mittal. I'm in 7th grade also with him. 12 years old, and I designed prototype 1.
So the problem is that in many countries, there are two things that take up the majority of the power bill, and that is heat and light. In cold regions, there is still a lot of sunlight, but it's still very cold, and people are still cold. And it's the same problem, except in places where there is a lot of light, but it's not easily accessible inside of buildings.
The solution we came up with is related to plants. Plants absorb light and heat, and we decided to use that principle, but building it with today's technology. So we used the 3D printer and built something using the UV rays from the sun to come to you.
Our second model represents a removable anti-parabolic mirror. Parabolic mirror is a type of mirror that just takes all of the light that comes into it and focuses it on one point. And so an anti-parabolic mirror is something that we made up so that it takes all the angles, it takes a single beam of light and it puts it through a bunch of angles, and to make it and to spread it out into a lot of even beams of light. And unlike our model, our actual prototype would have been removable to where you don't have to use it for light. You can also use it as heat, and you can use it to boil food or boil water to drink. And just like our original model, which we'll come up to next, this one also includes a two convex lenses, but they're not actually in our model, but they would have been if we could make a life-size model. And now to take a look at our original model.
This is model number 1. It may not seem for much, but you're packed for a lot. It's composed of one anti-parabolic mirror, one parabolic mirror, two convex lenses, foil, and a parabolic cone. It works like this. The UV rays are passed through the cone, where it reflects onto the parabolic mirror, where it reflects back onto the anti-parabolic mirror, and it spreads light and heat to the rooms. The prototype was good, but we decided to try something new.
Currently, 57 million kids across the globe don't have education. We estimate
that if this invention will be implemented, that number may go down.
We'd like to thank we'd like to thank everybody here at HCC, Mr. Fields for letting us use his 3D printer,
and the rest of the people who could help make this possible. Thank you.
So a lot of the kids have been thanking Mr. Fields. I actually have to tell you he's not here because on Friday night he was really sick. But then he opened up the lab on Saturday morning. He had a back pain, and he worked throughout Saturday. And then on Sunday morning, he called me up and said, "Ravi, I'm not feeling very well. I'm going to come by, just open the door for an hour." And then he didn't leave today until 5 p.m. That's Roland Fields. His dedication to working with our students is just amazing. So he's not here. He left, but he didn't leave until everybody's project was done. So I really want to thank and applaud Roland Fields of HCC for helping every one of these kids with their projects. And he's also the manager of that space back there. So, all right, Roland, thank you so much.
Oh, all right. Okay. Okay. Hi, I'm Nancy.
And I'm Anika.
And what we made is the bicycle wheel centrifuge. Can you go to the next slide? Okay, so basically the problem started when so we had a lab in biology where we had to work with centrifuges, and then I realized that a lot of them are bulky and they have to be plugged into energy sources. Not to mention that most of them mostly average around $100, and that's not really accessible to everyone. So what we try to do is that we try to expand on the values of making medical care and resources available to everyone, especially to those in third world countries who don't really have access to energy, and they might not have the money, or the government might not be able to provide that for them. So, yeah.
So we had to figure out, okay, so first we listed a few uses for a centrifuge. Like, for example, it can be used in hospitals to separate blood samples based on density. So you can find how much, for example, white blood cells a person has, or how much plasma they have. And it can also be used to separate the fat from milk to make a lot of foods like yogurt. So we wanted to make a centrifuge that could be effectively used in third world countries where they don't have much electricity or money. So here we use a bicycle wheel that we've nailed to a wooden block, and there's a cradle over here to hold the test tube, so that when the wheel spins, it can efficiently separate the blood samples based on density. And so you wrap this chain around the gear over here. And as you move the chain back and forth, the wheel spins. So basically what she's doing right now is attaching the chain to the gear, and as she moves it back and forth, the wheel spins fast enough to separate the blood samples that are held in this cradle.
Right, and the good thing about this product is actually the versatility of it, because we also understand that the audience that we're aiming at, they might not all live in the same environment, they might not all have the same resources. So the thing is, when you have a bicycle wheel that's, a lot of countries, they'll have bicycles instead of cars, especially towards the ones that we want to help. So they'll have a gear in the middle of the wheel, so if you don't have a chain like this, you can just use your hand, and they usually come like this, and you can just spin it just with your hand. And if you can find the bicycle chain, that's even better. You can use it to set up a system, and then use another gear to actually use a hand crank. And obviously the best possible choice would be having a motor, but also not everyone has a motor. So I feel like this is a very effective and has a lot of substitutes, so it could still work in a lot of circumstances.
So as you can see, this model is very effective for third world countries that don't have access to electricity or very much money, and it can be used for a variety of purposes. Thank you.
Greetings, everyone. My name is Basti Lazar, and I'm going to be presenting to you my energy project for this year's 2018 HCC inventathon. Can you go to the next slide? Okay. So I have made a product, or I've designed a product that will revolutionize the American average full-time worker. So average American, or like more than 30% of the American population, according to Forbes, work in full-time offices here in America, and they spend 47 hours a week, 6 days a week, average. So as y'all are sitting down, I can see some of y'all are shaking your legs because like usually people do that when they're nervous or when they're anxious or anything like that. So I have created this product that will change that motion to charge your phone, your battery, or anything like that. So go to the next slide. So introducing the electrical foot pedal generator. And yeah, so I got the inspiration from a sewing machine foot pedal and a hand cranked electrical generator. But there's one problem. When you want to make electricity out of a crank, you need circular motion, while your leg only does vertical or a linear motion. So I have created like a linear to circular motion converter that was inspired by a rack and pinion that was like they use rack and pinions for your steering wheel for a car. So can you go to the next slide? Press play. Hope it works. Okay, let me just it's not good enough. Yeah. Crank the electrical generator. Can you go to the next slide? So inside the electrical generator, I will have this electrical generator can output about or around 30 watts, which is pretty amazing. Like 30 watts is amazing. And if you add a DC converter, because it outputs AC, you can get up to you can set the dial to 3, 5, and all these volts outputs. Can you go to the next? Okay. Using this renovating product, you can charge your phone, which uses 5 volts, or laptops, or cameras, or batteries, or power banks. And next slide. So the benefits as emotions, you can relieve stress, and scientists have saw that when you move your leg up and down, that releases a chemical called dopamine, which basically is a happy chemical in your brain. So that can basically be kind of a happy chemical. And there's like health benefits, like you can waste calories, and energy you can be saving the environment. And what I've learned that to make an amazing product, you don't have to create something new. You can just use what's out there, bring ideas together, and make something happen. Thank y'all for listening, and I hope y'all vote for me.
I love you for bright Hi, I'm Neha.
I'm Hunming. Hello.
And this is the rechargeable hydropower. Okay, so what our project does is, so you, like the flow of water comes in through here and moves these spoons, and then this is connected in the system, and this can charge this battery we have here, and it's a rechargeable battery. So during the day, like this would charge this rechargeable battery with this power, and then it would cause this to light up during the night when you need the light.
Okay, so the idea for our project originally came when I'd recently been on a camping trip, right? And sometimes when you're going camping, there's those faucets and they have a basin, right? But the basin's drain doesn't go into the ground, but instead goes and it's like wasted as runoff and doesn't actually go anywhere. So we thought, okay, maybe if we use this excess water to power something that could actually be beneficial to the people who are camping. So what it does is basically, like she said, you turn it on, and then when the switch is on, especially at night, you turn on the water, and then when the water drains through the drain, next slide. And then it'll turn on the light. So basically, it was created to be useful to those who maybe had maybe you were in a campsite with no electricity, but you had running water.
Okay, so the reason our project is different from most like water wheels, because we see those daily, the main difference is that, especially in camping, it's really dark outside, so this charges it during the day and we can use it in the night, so like I mentioned before.
And yeah, so when you can just see when during the day when it runs, it charges the battery, and then at night the light turns on. Of course, this is just a prototype, and then a real thing, if we were to create something, it would be much more efficient and the light would be brighter. And then so alternatives. So of course this was created for a campsite, but you could also alter the product slightly so that in like more rural areas where, especially where it rained a lot, you can stick one of these underneath a water spout and have a unit to store electricity. So while it rained, it would work in a campsite too. While it rained, you would be able to store or generate electricity to store like in a backup generator in cases of emergency. Yeah. Okay.
And yeah, like I mentioned, it uses a rechargeable battery. Thank you.
The person you're trying to reach is not available right now. If you need further assistance, enter pound now. Please leave your name, number, and a message after the tone. Goodbye.
Good evening, everyone. I am Dhruva, he is Sukhjit, and he is Shubh. Our project is Green Sight. Green because it's efficient, and Sight because it helps the visually impaired navigate through cluttered environments. So, the next slide, please. So our project uses an ultrasonic sensor to obtain distances to objects and an Arduino to get that input and then set the buzzer frequency to basically help the visually impaired learn about the distance to the obstacle. And our project is especially energy efficient because it utilizes the information of the surrounding. For example, if it's a rural environment, it would only access the information from the ultrasonic sensor at a smaller interval and save energy. Oh, can you go back? Yeah. I have a quick demonstration here.
Our group took into account for two major factors when doing this project. The first of which is making navigation easier for the visually impaired individuals. As of currently, the majority of visually impaired individuals are heavily relied on using blind stick to get from one point to another. And this is really problematic because the blind stick doesn't really give a specific reference point for the visual in person, the point that they're getting towards. However, this is exactly what our glove changes because it gives them specific direction which they need to go to and makes navigation a whole lot easier. But then the second major factor that we took into was like making energy efficient products. As of currently, there are many alternatives to our group. However, the problem with all of them is that one, they're really costly, and two, they're not very energy efficient. Like, think about it. If a blind person has to change the battery 20 times just to go for a walk, it makes it practically impossible for them to use it. And this is exactly what our glove changes, as our glove can go for 48 hours without having to change a single battery.
So GreenSight solves the problem of global warming by minimizing energy consumption, which is important because when we decrease energy consumption, we decrease the amount of coal burned. Moreover, compared to the industry standard, our product has a constant runtime of 48 hours, detection range of 10 meters, and a travel range of 350 kilometers. When you have a travel range of 350 kilometers, you allow the visually impaired to walk long distances while being confident that they won't face the problem of dead batteries, which is what's happening in the alternatives such as walking sticks. So with our product, when it can last for 48 hours constantly, we give the visually impaired the opportunity to walk long distances. And this is crucial because we're helping the visually impaired, and B, we're decreasing the carbon footprint that we as a species leave on Earth. So this is why our product as a whole is a viable, practical solution to the massive problem of global warming. Thank you.
Good evening. My name is Hakeem Nabi.
David Kareem.
And Saj DeHanes.
And together we are Levitate. You'll never know until you fly. All right, our problem is, what if one day there will be no electricity and no fuel? there would be no fuel. What are we going to do to transport ourselves?
So our question was, if there's no fuel or electricity to power a car, what can we use? Our hypothesis was, we believe that we can use sunlight to power a car. So I'll pass it on to Sasha.
Next slide. Now, our car has the ability to levitate using solar power, and we made a car that can levitate, and it is powered by sun rays using solar panels. Now, our background research. A solar panel can work at night because it can also charge by the moon and the stars. Now, of course, it won't be as strong as it is powered by the sun, but as long as it has some kind of power, it will still be able to work at night. And then magnetic levitation is a method by which an object is suspended with no support other than magnetic fields. So basically, it's just powered by magnets, and it's just like connecting with each other. Now, our conclusion is our hypothesis is correct because you can power a car with sunlight just like you can power an electric car. It's just like powering a house because regular houses use electricity and they have electricity bills. Now, have you ever seen a house with a solar panel on the roof? That's basically what our car is, except the solar panels are built inside of the car.
And also, I'm going to walk around and show the judges our model.
Oh, now, you may think, how can this car move? Well, it's going to be a little bit tricky because it's levitating. So, in order for this car to move, we would need a booster so the car can move. And it'll just transport like any regular car. And the booster will be nitrogen, just to let you all know. Thank you all.
Hello everyone, my name is Saran Choka and this is Vibor Kumar, and we developed a desktop application called SkyPrint. Can you go to the next slide? So what is SkyPrint? SkyPrint is a cross-platform desktop application that saves paper by preventing unnecessary content from being printed. So what our perspective on this problem is that it has a user-friendly GUI, a graphics user interface, that uses browser automation to remove the unnecessary content. What this does is that, sure, there's so many softwares out there that allow you to save paper, but ours is a GUI. It's very user-friendly, and you can just print green-friendly with just one click. So we take on a different perspective because it does everything for you, and it can be integrated into people's daily lives. So why do we need SkyPrint? So according to statistics, 45% of printed paper, they end up in trash. It's because of unnecessary content being printed or unnecessary pages like advertisements, URLs, or content that you don't even need. That's according to that come from human errors, or you don't cite things that you don't need. So have you ever like gone to a website and you wanted to print out something, and then you have all these unnecessary images that you wanted to print out, all these unnecessary URLs or text that don't even relate to the articles. So what our software does is that it filters all of it out and outputs a PDF that can be printed in a green-friendly way. So the environmental effects of waste paper is first deforestation. So the more the paper that we use, there'll be more deforestation. And every tree produced, it provides oxygen for 3 people to breathe. And there's paper pollution too, because if paper rots, it emits gas, which is more toxic than CO2. So there are like tons of like environmental effects. So if you're able to save like billions and billions of paper, we'll have a huge environmental impact around the globe. So next.
Okay, so this is our GUI, and we made it super simple and easy to use, so it's more accessible for everyone. So all it requires is you to enter your URL, and it'll process whatever URL you enter. And since it's just a prototype and we didn't have enough time to implement a splash screen or a loading symbol or anything like that, but as you can see in the background in the console, there's processes going on. The program is processing the URL, and it's showing the, and then it will output the PDF as a file.
So we did the backward networking in Java, and then we did the GUI in HTML and CSS. So after it's done, you have to click OK. It has returned a PDF document, and which we'll compare, and which we'll be comparing the next slide. So so this is an article from Newsweek, and when you press Command P and we got a preview of it, this was the first page. There's a lot of unnecessary white space, and there's a bunch of like tags that we don't even need to print out. But then you look at our software, which like gives you like only the necessary content that you need, removes all the white space, and it removes the unnecessary URLs that are not needed. It also gives you the author and the hyperlink, which is all that you need. And another output is that first, our software was able to remove the image and the caption underneath it. And if you see this line over here, it's a part of the article, but it has nothing to do with the content. So what articles usually do is that they put a lot of like advertisements between content. So we don't need them, right, when we print them out. So it automatically removes it. And moreover, we built this app like under less than 24 hours, and we were able to save like 4 pages. So if you actually printed this out, this would be page 6. But then when we actually like print it out with our software, this is page 2. So with like an application that we built under 24 hours, we were able to save 4 pages. Just imagine an application that we complete, we'd be able to save tons and tons of money and ink. So these are the features. It removes images, it removes image captions, advertisements, and hyperlinks that link into advertisements. The net benefit of this software is that it does everything for you so that the user doesn't have to go into everything.
Okay, so our project is, we open sourced our project, and what this does is it allows people all over the world, millions and millions of people who know how to program, to help and contribute to this software. So looking into the future, this could become really big by being integrated into many, people can use this in operating systems, in offices, and you can have, there can be many, many benefits to using this type of software in the future.
So I believe this is the last presentation, but before we, is there anyone that did not make it into, there's 4 more, okay. So So do we have them in our list? So what we print, so there's technically 4 more after this, 5 more after, including this. So 5 total. 5 more presentations to go. So, all right. Wow, you guys really were inventing. Does that make us bring us up to 20? So we're at 20 presentations. Wow. All right. So bike energy.
Okay, so our project is called Bike Energy. I'm Raymond.
I'm Bill.
I'm Venru. So what we designed is a regenerative braking system. Essentially what this does is it converts the kinetic energy of a bike, which is usually lost during braking due to friction, and it converts that into electrical potential, which then can be used to charge any USB device. So for our device, we have a fully functioning prototype that, regenerative braking in e-bikes already exists. However, ours is slightly different. And give us a break. So what our e-bike does is it not only is it universal and can be used on any kind of bike, not just electric bikes, but it can be used on any sort of normal road bikes and things like that. It also uses a proprietary supercapacitor buffer system. Essentially what this means is that it stores most of the energy from braking into a supercapacitor, which can accept high charge currents compared to normal lithium-ion batteries, which can't really. I'll go more into detail about this later.
Okay, so this is just a picture of our user interface. I'd like to demonstrate to the judges for a quick second. This code is responsible for 3 things. Taking in the user input from the either the throttle or the slider on the LCD touchscreen. And then second, controlling the brake force that's applied to the motor. And then third, regulating the transfer of charge from the supercap to the batteries.
So this is the circuit diagram. I will give you a quick introduction of what it is. Essentially what it begins off as is a 3-phase bridge rectifier. We used a 3-phase bridge rectifier over a normal full bridge rectifier because we used a 3-phase brushless motor. We did this because it doesn't have brushes, so it negates brush wearing, and it's much more efficient than normal brush DC motor. After the bridge rectifier, the energy is then transferred to a supercapacitor, which is 500 farads. That's a very high capacity supercapacitor. And the reason we do this is because unlike lithium-ion battery packs or just lithium-ion batteries, supercapacitors can be charged at a much higher current. This supercapacitor can be charged at several hundred amps, where in areas a lithium-ion battery of similar size can only handle like 5 or 6 amps. The voltage from its supercapacitor is then boosted using a boost converter module up to 4.2 volts, which is then sent to a regulating circuit, which regulates the lithium-ion battery pack. Now, the reason why we transfer the energy from the supercapacitor into a lithium-ion battery pack is because the supercapacitor has a very high leakage current along with other capacitors. This means a lot of it will discharge by itself. Now, lithium-ion batteries, lithium-ion batteries have much higher energy densities and much lower discharge current. So after that, we increase the voltage to 5 volts and send it to a USB port, which can charge any USB device. That's the Arduino Nano.
All right, so hello, I'm Murtaza.
And I'm Alan.
And we made an energy efficiency calculator. Okay, so first of all, what was our goal? So given the theme of energy and how we can evolve and advance in ways of obtaining this valuable resource, we wanted to create something that helped display the benefits and pitfalls of different sources of energy and sort of rank them in certain situations. So our invention. So our invention is a combination of software and hardware. We designed an algorithm that rated the efficiencies and values of different substances in certain situations and based on constraints of time and energy needed.
All right, so in order to complete this, we can you go back? All right, so we created a motorized wheel of fortune type spinner, and then of sorts to display the common energy generating substances, which would be best fitting for a proprietary scoring system.
All right, so first, the main part of this is the algorithm. So the robot is sort of just a displaying mechanism to help visualize what the algorithm is doing. So how the algorithm works is that it uses sets of data regarding the cost, energy density, environmental friendliness, and abundance of each substance to decipher how proficient they'll be in given situations of time and energy required. It then ranks these values and decides which energy suits the situation best. And all this is based off of our research, and we use sources like ExxonMobil, BP, data from the Texas National Environment Association, something around those lines. All right,
so the hardware aspect works like this. So the robot waits for the algorithm to complete its task, and then once the algorithm says how long to turn and for how much power, it displays it by spinning the black disc, and then it shows you like which energy is most efficient for the certain constraints.
You can just skip this video because we're just going to show you. So say, yeah. So so we have two inputs. First, the code it asks you. I'll read the prompt. For what period of time do you need the energy? So we'll say 60 years. Okay, so we'll put in 60 years. All right, because we're doing this for long term. It's our futures. Right now, we know what energies we're using, so for the future. And then we're gonna say it's asking how much energy do you need, and then in joules. So we're gonna say 120 million joules. All right, and then this will go. It'll tell you. It will rotate that, and this has told you that for the next 60 years to generate that kind of energy, natural gas will be the most reliable of the sources. And then to show you that it's not a fluke and it's not just running the natural gas, and we didn't just say, hey, motor, run this long every time. We're going to go, let's say, 10 years and 120 million joules again, just for it. And that went to petroleum. So here's the further explanation. So the algorithm rewards substances for factors such as their energy density and cost effectiveness. And then after establishing these mean values for cost and abundance, it deducts the scores of the substances that fall below the averages by removing incremental percentages. It then adds and deducts points for environmental friendliness. So for example, if I want oil and a certain amount of joules of oil for a span of like 97 years, it will deduct points from oil because oil, according to scientists, will be gone from our planet within 53 years. So it's not a reliable source. So then it'll divert to something else like natural gas and hydroelectric. And thank you all for your time.
Good evening. My name is Camila Muhammad.
My name is Abdul Kareem Nasir Muhammad.
My name is Naila Muhammad. My name is Naja Muhammad. The purpose of wireless charging is, well, the question that we want to ask the audience is, how many of you all have lost your chargers before? Yes? Okay. Well, if so, we came up with a solution to that problem. Our wireless charging device invention is powered by Wi-Fi. Therefore, if you get in a situation where your phone is about to die, all you have to do is connect to the Y charger.
Okay, now normal Wi-Fi routers use radio frequencies that they use the satellite and generate just enough radio frequency so that you would be able to connect to the Wi-Fi around you. What we would do is better focus that energy, better focus that radio signal through Wi-Fi charger. How this works is that it's converted to DC via a small embedded chip inside of the product and can only be generated from 15 feet away maximum. So as you can see here, well, I'll flip it around for you. This is the phone, and this is the difference between the Wi-Fi box and the Y charger box. As you can see, I kind of made the lines weaker to represent the radio signals being given to the phone, as opposed to the radio signals being given to the Y charger. As you can see, the Y charger's radio signals are stronger, so that energy would be able to you would actually be able to energize the phone with the charger.
This is the demonstration of how it will appear on your phone. Below your personal hotspot, for those who have a personal hotspot or an Apple phone, you will see the Wi-Fi charging, and then once you click on it, there's several different options that you can choose depending on what type of technology you are using at that point. So if you are we have public and private domains. So if you're at your home, of course, you have your own Wi-Fi, so you will need your own password, versus when you're at a public space with it, like Starbucks, a certain amount of watts will be let out to each device, so that everybody will have the opportunity to use the Wi-Fi charger.
Next slide. So usually people use the wireless conduction, which is a power transfer using a conductor to connect two electronics devices in order to transfer energy. However, we use the wireless transmission, which is a wireless system, consists of two main components, a transmitter and a receiver. The transmitter handles the conversion of the audio signal into the radio signal and broadcasts it as a radio wave via an antenna. The antenna may stick out from the bottom of the transmitter, or it may be concealed inside. Thank you all for listening.
Hello, everybody. This is our project. So for the first slide, welcome to Houston, or H-Town, whatever fits for you. It's the largest city in the U.S., which means we also have some of the most biggest energy industries in the world. And because Houston is so big and has so many subdivisions, that means we're going to need a lot of energy to keep us moving for the next generations coming up. So the first things, one of the first things we asked ourselves when we were trying to figure out a better way to generate electricity for Houston, as well as come up with a water distribution system and purification system, we asked ourselves these questions, basically trying to get the length of Houston, the amount of people per mile, and also trying to get statistics as it pertains to hurricanes and misplacement and things regarding that. And also to take note of the fact that there are several trillions of gallons of water that are wasted, and that we could use that water not only to purify and to store, but to also generate electricity. I'm sorry. Go back one second. All right, so let's just go over what we know about Houston. We know we have a population of 2.2 million people. We also know, like I said, we are the fourth largest city in the country. We know Houston is 15 meters above sea level. We know that northwest Houston is 38 meters above sea level. And we know that Houston stretches that 8,778 square miles. And that it overfloods about 4 to 5 times a year, which is...
What is energy? In physics, energy is the quantitative property that must be transferred to an object in order to perform work on or to heat the object. For instance, like solar, hydroelectric, wind, tidal, natural gas, and petroleum energy. Next slide.
Hydroelectric power. What is that? Hydroelectric power is using water and hydropower generator to create electricity. So our project, what we used, we made a hydroelectric generator to basically to power the city of Houston. We have the generator right here and the turbine, and what happens is the water goes through the turbine and it spins, and as it spins, it causes electricity from the generator. After that, the electricity will travel through the city of Houston, powering the city. So what we did is we have a wheel in the center of the city where the electricity will transfer to the wheel, therefore it powering the city of Houston.
So, some of the other components of the invention is that, like we said, it overflows about 4 to 5 times a year in Houston. Now, one of the things that we know about this flood water is this flood water just comes through, picks up toxic dirt, things like that, and it goes straight back to the Gulf, which means not only are we dying, but sea animals are dying, and that's or the atmosphere. So one of the things this does is our generator kind of generates the water, distributes it to a tower, which we call it the water bank, which stores the water, and it has a purification system that happens, and then that water gets purified and then sent back to the Gulf, and some of this purified water gets sent to some of the water pipes. So that means purified water in everybody's homes for everybody.
It's not actually the atmosphere that's being infected, but it's the hydrosphere that's infected, since it's dealing with water.
Thank you.
Okay, last presentation of the day. Let's go with the bang, am I right? Okay, so somnambulism or sleepwalking is a very widespread problem, especially in the US. So more than 8.4 million Americans sleepwalk each year. So, and this risks harm to not only themselves, but other people around them. The tragic number of people harmed by somnambulism or sleepwalking can be easily avoided through a simple engineering solution. So the solution is our technology, Push Alert. So Push Alert is integrated with several modules embedded into a piece of footwear. So first, we have a mechanoreceptor. This is a button or mechanical receptor embedded flush into the heel or sole of the shoe. Then we have a Bluetooth module. So this HC05 Bluetooth module, when integrated with a master device, such as a mobile application or a computer application, it can send data regarding the footsteps and the step times and duration. And it can also notify a preset phone number. And then we have a 3.3 volt buzzer integrated into the shoe. So whenever a user steps onto a surface during sleepwalking, this notifies them and wakes them up early so they can avoid causing harm to others. And when applied in the real world, the Push Alert system will notify the user when it detects sleepwalking, preventing harm as early as possible, and it will also notify a contact or the authorities. So our product combines current technology with any form of footwear chosen by the user to ensure safety for the impaired. So this product and application can serve millions of Americans who suffer from sleepwalking.
So essentially what we did was we used this mechanoreceptor to, additionally with a machine learning algorithm, to find the relationship between pressure, force, and area, which what we found was that pressure was proportional to 1 over the area and also proportional with the force. And then when we graphed this, we found that it looked quite similar to the existing sine wave that we all know. And then we also wanted to do some research on regarding the area under the curve of this graph, along with the intensity or stress on the patient's foot, so that over time the machine itself can teach itself to be more efficient as it's being used by the user. So what we did to find this relationship was we integrated this sine wave that we have here, evaluated from 0 through L. So in order to evaluate it, we essentially calculated the negative cosine of L, subtracted from the negative cosine of 0, which essentially left us with the negative cosine of just L. And then we also had a multitude of things that we wanted to optimize, for example, cost, efficiency, time, etc., which gave us a multitude of layers which would be present in our neural network. So before we started to fabricate the neural network, we decided to sort of lay out what we had within our hands. So the sort of logic that we use is well known as Lagrange multipliers, in which case we have a multitude of functions, each of which map to the separate layer on the neural network. For example, as I stated earlier, cost, time, efficiency, usability, etc. And we wanted to obviously find the best conditions for the user, so it's not too expensive, and it's also easy to use, because we also found that most people who have this disability are quite old as well. So we didn't want to make a completely new system because it would also be very hard to learn, and we wanted to make it easily accessible. So instead of using the Lagrange multipliers themselves, which introduce a new variable called the, we essentially transferred this over to our program.
So let's go into detail about the machine learning portion of our project. So to create the optimal product with an optimal button placement and all the components in the exact right place and order, we decided to build an artificial neural network to implement into our project. So Push Alert has an artificial neural network that analyzes the footstep patterns and gait of individuals suffering from somnambulism or sleepwalking. So we use a source, a database by a man called Gabriel Bovey, which analyzed the kinetic reference data for adult subjects suffering from sleepwalking. So for the neural network, we use the sigmoid function. And this allows for a more accurate and efficient network. And you can see here that it's a gradual gradient. So we receive 4 primary data points as output from the network. And you can see, we can see that the button placement was optimized using this neural network and allows for the best product possible. So in programming the device, we had several challenges to consider from our research that we conducted in math. And you can see here portions of our code. Thank you.
All 20 teams. So I'd just like to remind the judges that they started yesterday at 9 a.m. and they're presenting all of their projects today. So within 20 hours, this is all that they had created. Please pass all your grading to our scorers, and then we'll take a 10 to probably 15 minutes to score all of them. And then we'll announce the winners tonight, so just hang around. There's some food in the back, there's some water in the back. And then, and also, all the students, help us clean this area. Go ahead and start putting up the tables, start taking the seats, put them back in the classrooms. We do have to put everything back the way we had found it on Saturday morning. So please start putting the chairs back in the computer room. Start folding the tables and put them all here in the end. So let's make sure, and then clean up the space. Clean up all the spaces, please. Hello, everyone. Please help us clean the campus as well. If you see trash anywhere, throw it in the trash cans. Just walk around. I see some paper, some regular plastic bottles. If no one's using them, go ahead and trash them. Please clean this campus. Appreciate all of you.
Look, you and me on the Charles River. I could die right now, Glenn. I'm just happier. I've never felt that before.
There's a group of students who are throwing trash in the back dumpster. Just help them out. If you see a big trash can full of like things like that, go ahead and help them. There's a dumpster. Just someone stay at the door so they can come back in. Go as a group and then help us throw the trash away. Any one of y'all that's standing here, please help out. This will also give us time. Just take the trash and dumpster in the back. You can take the last wing, throw the trash away. Just make sure someone's standing at the door to let you back in. Most. I've got t-shirts that I'm going to be giving out. So those who are helping the most in teams, the ones I don't see here, will get t-shirts.
What do we call this? What if we become insanity taking over me? Is this insanity taking over?
If we run out, I'm sorry, so get everybody back in here. we're gonna wrap this up. The suspension's over. Just let's get the judges up here. Everybody else, please make some room up here. Stand in the back. Just make some room so we can get the winners up here for a photo up with our judges. I realize it's Sunday night, so we're gonna try to wrap this up quickly. However, I have to tell you, if you do win something, there is a form I need you to fill out, so don't just leave after winning. The judges can leave. But if you win the prizes, then there are forms that you and your parents should fill out. If without the forms, we are not able to mail you your check. And please make sure they're completely filled and signed. Otherwise, HCC will not able to mail you your checks, okay? It's been a long process in the past when we don't have someone signing correctly or their socials not correctly typed, and then it's just a very long process to get your checks out to you. I also want to tell you that if a team wins and you decide that one of you will get the check and then split it amongst yourself, that's totally fine. One person from the team can fill out the form, or if you want, you can have it split between the teams. I believe the first place is $400, second place $300, and third place $200, and fourth is $100. And fourth is dedicated to Mr. Roland Fields. It's the Roland Fields. Well, he's not here, as I mentioned, but for all that he does, we wanted to have an award on his name. So, do we have the slides? So I'll let Nikhil announce the fourth place. And that's for the Roland Fields. All right, go for it.
So, okay, so the field medal, notice it's a very big medal. The Fields medal goes to Jolt. Like, you know, they take those pictures with big checks. Yeah. Okay, slide over here. No, don't stand in front of the screen. All right. Okay. So our third place medal goes to Bike Energy.
Bike Energy. Oh, come. Take photos. Wow.
Yeah, perfect.
Hey guys, just quick photos. One of you, please.
I hope I'm not just Yep. The grand prize winner is Skyprint. Yeah. Get everyone Everyone still here, stay here. We're going to take a grand picture with every single person that's still here. Yeah, more t-shirts for people who stay. Okay. Okay. What's up? Okay, stay here. Yo, don't leave. We're going to take a picture. Just gather right there next to gather next to Bill in the green shirt. Okay. Guys, gather over there. Okay. All the winners and all the people who are still here, please gather right here.